Hi, and welcome to another episode of Inside DFINITY. Today, I'm going to have conversations with people that have just started working on our scholarship program or have finished it in the past. And I'm going to be talking to them about what they're going to be researching, but also how did they find out about the scholarship program? How did they get started? How did they get in touch with DFINITY? That's what we're going to be talking about. And without further ado, please enjoy some of my conversations with these scholarship participants. Maybe we could start by you giving a quick intro and telling us who you are, where you are right now, and what it is that you do.
I'm Cédric. I'm a PhD student at MIT, and I'm very happy to be part of the DFINITY Scholarship. I'm in CCEL, part of the theory group of the EECS department. My advisor is Shafi Goldwasser, and my research is mainly on cryptography.
So my name is Goran Žužić. I am a PhD student at Carnegie Mellon University. I am advised by Professor Bernard Heuper. I work in the theory of distributed computing. We'll talk a little bit more about that later. I was born and raised in Croatia. I lived there all my life, and I came here like 3 years to Carnegie Mellon, and that's in Pittsburgh. And I've been working on distributed computing ever since, and it's been doing great.
My name is Aparna. I'm currently a Teal Fellow.
I'm Zubin. I just actually graduated from UC Berkeley.
I'm currently studying electrical engineering and computer science at UC Berkeley. Founded She256 with a couple other people here at Berkeley, which is an organization to increase diversity and break down barriers to entry in the blockchain space.
Sounds awesome. And what are some of the topics that you work on?
The broad area would be called like the theory of distributed computing. And the best way to imagine it is the following. So suppose you have a distributed network of many nodes, and you want to compute some global properties of the network. For instance, you want to compute the shortest path between two nodes. Imagine one computer is in Croatia, the other one is in the United States, and you want to compute what is the fastest way to communicate between them. Now, you want to keep this nice and decentralized, that I'm sure DFINITY wants to do, and so nobody knows the entire network in the beginning, and nodes have to communicate this network information. They need to figure out what is the best way to communicate between themselves, propagate this network information, and actually be able to compute the shortest path or some other property at the end.
And my research title is doing a secure MPC, multi-party computation, when not all the players are online all the time.
Right now, we're a host of different experiments. We're primarily focusing on 3 kinds of different innovation. The first is making it easy for new researchers to understand all the knowledge that exists in this space through different survey of knowledge kinds of papers. The second experiment is basically focused on how you can create a scalable peer review process. The third experiment that we're kind of focusing on is a lot of exploration on the incentive design and blockchain space.
So you are part of our current batch of scholarships of the DFINITY Scholarship Program. How did you first hear about the DFINITY Scholarship Program, and what did the process look like so that someone watching this video who might be interested in doing research in this area as well could know how to get there where you guys are right now?
I guess we were really lucky in the sense that we had been working with Manoush for a while on our earlier paper. And Manoush was always like, she's a great mentor. She was super encouraging, and she would always like point us towards different opportunities or places that we should consider publishing our paper or people we should talk to. And she mentioned the DFINITY Scholarship Program, and she was like, you guys should definitely apply. I think the next steps for us was to figure out what we wanted to keep working on. We've been working out and narrowing down like the scope of what we wanted to do.
I heard it from my advisor, She talked to me about it, and then I look online and I read in the blogs and the places in the internet and saw even few YouTube videos.
Well, given the cutting edge work that DFINITY wants to do, it makes sense for DFINITY researchers to work with academic researchers. So one of your senior research scientists, she was collaborating with my advisor, Professor Heuper, who is one of the top guys in the theory of distributed computing. So he was familiar with the company and the work that you do. And once DFINITY announced their scholarship program, he pointed it out for me. I got interested, I read up on it, I figured out that my work actually could be helpful, and I applied. I wrote a proposal and applied.
Great. And what was the proposal about? What did you research? What did you do research on for DFINITY?
We thought about two projects. One, I think, is more, we thought about it even much more, like how to do the sleepy MPC and using the blockchain. It's a joint work also. It's not a work yet, it's a project together also with the El Kalai. She's in Microsoft Research. We are thinking about how we can do a multi-party computation using the blockchain, that it's a new technology, but now maybe the number of players can be different in each step of the computation, and also the number of players are not fixed in advance. Honest players can not have to be online all the time, and how we can do computation in a secure and private way in this setting that is more realistic in the world we are living today.
It would be these fundamental questions on a distributed network, best way to synchronize parts of the network, best way to solve some global problems on it. Another types of global problems, except the shortest path, would be, let's say you want to compute the minimum spanning tree, or you want to find the minimum cut. So how many computers or links would an adversary need to kick out in order to disable the network? So the question is, how would you compute such things? Or maybe another way to see the work the work that I'm doing is, these days when you have all the CPUs in a computer, you can imagine there are so many CPUs that you can imagine it as being a distributed network. Mm-hmm. So how would these CPUs need to communicate with each other in order to propagate information in the best way to synchronize between each other, make some kind of a barrier or a partwise barrier synchronization?
The DFINITY scholarship, I think, primarily is focused on the incentives experiment. Mm-hmm. Zubin, do you want to elaborate a little on that?
Yeah, so talking about proof of stake, as we went through the meta-analysis that we've already done with Manoush on different alternative consensus systems, the glaring missing variable in the field was that none of these had reward systems. And proof of stake, it's fundamentally based on the reward system of the network, because it's about putting coins and believing that as a result of the incentives, people are going to act honestly and they're going to be good validators in the system. And so we saw time and time again, as we looked at different protocols, they would leave this variable out. And so that's something, kind of looking into how you can build optimal incentives in proof of stake is something that we find really interesting. And so we are working on that very, very hard.
Very cool, guys. Anything else you would like to add or say to someone who might be watching this video and informing themselves about the DFINITY scholarship program or Mechanism Labs?
Yeah, I would say definitely apply. I think that it's a good learning process. The DFINITY team is great. They've been really helpful in helping us. Manoush has been a great mentor to us. I think that this is a great opportunity, and you should definitely apply if you're interested in research in blockchain.
Cool. An exciting time, and I'm looking forward to check in later and see what you've discovered along the way.